So I had a customer ship us some of the material. It's a U.S. manufacturer of earth moving equipment, and right now they manufacture these thumbs and other components of these excavating buckets out of AR400s and abrasion resistant material. It's about 155,000 yield, which is probably 4 times the average yield of like an A36 mild steel. Right now, after it's coming off of the plasma, they have to hand grind it, and doing a lot of parts each day, almost 200 parts. It's a full-time job, 2 guys hand grinding this. So what we're gonna do is run these through an Apex Easy Sander and see if we can get off this mill scale a lot easier, a lot faster, and see if we can get it ready to weld without hand grinding. So normally I'd be running this with like a ceramic belt. The only, ceramic's a very sharp media, but the only ceramic belt that I have is 120 grit. So this is a zirconia belt, which is gonna be a harder material than aluminum oxide. It's gonna hold up a lot longer than like a standard brown aluminum oxide belt. So this is an 80 grit. I think that'll perform probably better than that 120 ceramic that we have. So first thing I wanna do is show the belt change. If I were to do this in production, I'd probably be running like a 36 grit ceramic, because it's not so much the look, but it's a, you know, it's getting that material removed as fast as possible. This will put probably an 80 grit's like a medium grain finish. Let's swap out the belt, because right now I have a aluminum oxide belt on here. So we're gonna loosen the belt tension, pull this pin, belt slides off. I'm trying to put this on without blocking the view. Alright, so that's our belt change. Tighten that up. So inside the machine, we have a laser eye here for the belt tracking. So that'll keep the belt on track. And then we also have these E-stops right here if it were to, for some reason, fail. Or if you, a 3-phase machine, if you have it wired backwards and this isn't working, the belt will off track hit these and stop, so it's not like crashing into the door. Next step, I want to see how thick our material actually is. We have 2 different thicknesses here. This is about 1 1/4, so we can take our calipers and just kind of gauge the actual thickness here. So we're going to set this machine up to grind. So we're at 1.13. Let's take one more bite at that. This is actually 1 inch. This is 1.018. And then this right here is a little thicker. You can see this has got a lot of heavier dross on here. This right here will chip right off, and it's actually not too bad. We'll see how it performs. So right here's 1.255. All right, so now we're gonna set the machine up to run the first part. But you have a digital readout, and the conveyor has an electric adjust, and then on the side of the machine you have a fine tune. So I'm gonna lower the conveyor down to 1.018 inches, so 1.02. The 2000 series machine, which is a heavier duty machine, you can run that thing like 2 shifts a day. You can actually dial in the thickness. Type in 1.018, it'll go to it. So that's a nice feature of the 2000 series machines. You don't have to stand here and dial it in yourself. It also has 4 lifting points on the 2000 series machine, makes it a little more rigid. Probably better for this heavier material. I would definitely recommend running this material on conveyor. All right, so I'm getting this down to 1.015. I'll come to my side of the machine and just get that adjusted a little bit more. It's actually like a really fine adjustment, so like a quarter turn or so. That's all you need. All right, 1.185. So we're gonna set the conveyor. I'm gonna start this at like 2.5. Being such hard metal, I want it to really grind under that belt. So we're gonna go a lot slower than I normally would on like a thinner piece of mild steel. Start it up. Already moved a lot of that mill scale. We're gonna now come around this way. To do our fine adjustment, we work off this handle. So I'm gonna give this one full rotation. After that, I'll probably only go a quarter to a half turn at once. So let's run this through one more time. Do like a half a turn right here. Run it through one more time. Normally I'd be staggering my parts. Just kind of want to see how this belt holds up in one spot. So I mean, that's ready. What I was talking about, like dialing in the machine, now that it's set for this thickness, we'll run it in here and we're going to get a lot of that off in one pass. Got some of that slag there from the plasma. There we go, it's like one pass. We can maybe do a quarter of a turn. Always going clockwise to get that belt closer to the grinding head. All right. I think that one's ready to go. Let's put the next piece through. Pass. It's our second pass there. Here, follow this one through to the back of the machine. Run that through one more time. And we're not really looking to remove all this, we're just trying to get this ready to weld. So I think this one's 100% ready to go. But we'll send this out to the client and see if it's good enough for them. Set it to do 1 1/4 inch. So we're going to drop the conveyor down to 1 1/4. 1.255. There you go, 1.2245. That's close enough. So This guy's gonna be a little heavier, but let's get this one going through. You can see the amount of slag on that from the plasma. That's gonna be gone in one pass. So that heavy piece there, personally, seeing that it kind of welded to the metal passing through that grinding head, I'd be knocking that off with like a metal hammer first. I could have knocked that off. I just wanted to see how that would run. Everything else is pretty much clean, ready to roll. Let's pass it through one more time. Came off on the second pass, but that heavy stuff, just chip that off with a hammer. I think we're good to go. We could, you know what, I didn't even dial that one down. It was kind of right on the money. We could do half a turn on there. We're looking at. So that beats hand grinding, and you can just keep feeding them in. And this stuff's so heavy, I would definitely put an in-feed, out-feed conveyor on it. And like I said, we might want to look at the heavier machine so we can get a machine with 4 lifting points on the table, being that this AR400 is so darn heavy. You can see on the apex, this conveyor belt, you have 2 lifting jacks, 1 on each side. On the 2000 series, you have 4 of them, nice and squared up, and it makes this can hold a lot more weight and take a lot more abuse, because if you're not running a conveyor, even if you are, guys are just gonna be slamming these heavy parts on this, and you know, that's a lot of wear and tear on those jacks. That pretty much sums it up here. This guy's a little too heavy for me to do on my own, so we're gonna leave that there.